name is Tuwarasan. My material is 01EE24 F1070.
So today I will explain about mini hydropower plant using water tanks and rainwater harvesting. So let's look at the location I chose for this experiment. So the location I chose for this experiment is a building that near to JKE where there is access to large rooftop area for rainwater collection and elevated water tank. So this will be the block diagram for this experiment. First we will collect the rainwater. The collected rainwater will flow to the water tank, and the water that collected in water tank will flow through the penstock pipe and create high pressure. The pressure will spin the turbine and create a kinetic energy, and the kinetic energy will turn into electric energy by a generator, and the electrical output is created, and the electrical output will be used in the JKE buildings. Next, I would like to talk about justification for the location I chose. So first of all, the rooftop can capture large amount of rainwater, reducing dependence on external water resources. Next, the elevated water tanks provide the height, which is I consider as height, needed for water to flow with enough pressure to drive a turbine. Next, it's easy to connect to the existing building electrical system for demonstration and educational purpose. Furthermore, it is also close to students and staff for continuous monitoring, learning and improvement. For the last, it is minimizing piping costs since the water tank is already part of the building infrastructure. For the next part of this video, I would like to talk about parameters that we will use in this experiment. First will be water height, the vertical height between water source and turbine. The higher the height, the more power will be generated. Next will be flow rate, volume of water per second. Other than that, turbine efficiency. Choose an efficient small turbine like Pelton, Togo and etc. Other than that, generated capacity matched to turbine output, small synchronous or permanent magnet generator. And last will be storage capacity, size of water tank to ensure continuous supply even in dry weather. So let's look at the impact of this experiment. The first impact will be educational impact. It acts as a live demonstration for students studying renewable energy and electrical system. Next will be community benefit. Promotes awareness of clean energy and sustainability practices. Other than that, environmental impact. Zero carbon emissions during operation, uses renewable water source. Other than that, sustainability. Reduces reliance on fossil fuels, lower electricity costs for JKE. Lastly, innovation. Encourages future engineers to design and improve small-scale renewable systems. As a last part of this video, I would like to talk about components that we will use in this experiment. First will be rainwater harvesting system, gutlers, filters and downpipes. Second will be water storage tank, elevated for gravitational head. Third will be penstock pipe, which will direct water from tank to turbine. Next will be mini turbine, convert kinetic energy to mechanical energy. Other than that, generator, convert mechanical energy to electrical energy. So the following will be controlling system, which is control voltage regulation and load control. Other than that, we will also use power distribution, wiring to supply loads in JKE. The last will be spillway or overflow system, which will prevent flooding during heavy rains.